This lesson is no problem. You guys will cruise. You just got to be careful about a couple little details, but you should be fine. All right. Um, this here probably, if you're taking notes in your notebook, this here is probably a good thing to just um, indicate. All right. That's what you can use most of the time. Occasionally, a problem will ask you just for the lateral surface area, and then you'll need to use this. Only this, but most of the time you're just going to be finding the surface area. One thing that you'll have to be careful of as you go is that radius. If they give you all the way across the circle, which is the diameter, you'll have to cut it in half to plug in the radius. All right, so let's waste no time here. Let's check this out. In the video that you've watched previously, hopefully you realize that there's two bases, and then there's this curved surface that when you snip it down the center of it, like through the height of the cylinder, and you unroll it and lay it flat, it becomes a rectangle. The one length of that rectangle is actually what the length that wraps around the circle. And when we wrap around a circle, we're measuring circumference. So that one dimension of the curved surface is the circumference of the circle. And then you're just going to multiply it by the other dimension of the circle, and that's the height. So total, we have the area of the two circles, 2 pi r squared, and then you have the area of this rectangle, which becomes 2 pi r times the height. All right, so that's how the formula was derived. That's where it comes from. And then you can read through this to figure out some of the other information. Anyway, lateral area is that curved surface. It's the area of the surfaces that aren't the base. Lateral surfaces are just non-base surfaces. All right, let's go. Moving on. So you can, I'm sure, read through these examples pretty easily yourself and understand what's going on. I think they're pretty clear. Make sure you read the directions because that can trip you up. For instance, example 2, if you don't read the directions, you'll do a little bit too much work. Anyway, so we're finding the surface area of the cylinder, the whole surface area, not the lateral area, but the surface area. So we just write down the formula, and then we substitute in the right numbers, and then we calculate. Now, since they didn't tell you to use an approximation for pi, then you should use the pi button and then just round your answer at the very end. If you don't have a pi button, well, just do your best with some approximation like 3.14 probably is the best idea. All right, so calculate all that. You should get that answer. Go ahead and pause and try these two. All right, I'll show my work over to the left. When you unpause, you can see if you got it right. If you didn't, review it and figure out where you went wrong so you can learn from your mistakes. First thing is I'm going to write down the formula. So we have 2 pi RH plus 2 pi r squared. And we're going to plug in the right numbers. I'm going to just use the pi symbol here, but the radius of part A, we're on part A. The radius is given, and that's 3. The height always connects the two bases, so that would be 9. We're going to add that to 2 times pi times the radius squared, which is 3 times 3, or 3 squared. And now we just have to calculate. So I'm going to go to my calculator, and I'm going to do 2 times, where's my pi button? Ooh, I can't find it. There it is. Times pi times, let's see, what did I have there? Oops, wrong button to press. Okay, 2 times pi times 3 times 9. 2 times pi times 3 times 9. And that gives me that. And let's see, what else do I have? 2 times pi times 3 times 3. 2 times pi times 3 times 3. And I get 226.2. Does it say to round in the nearest tenth? Yes, it does. So let's press equals here. 229.19, which rounds up to 226.2. All right. So that comes to approximately 226.2. And since we're doing Surface area, anytime we have area, that's a flat surface, which is 2 dimensions, so it's going to be squared. So that's going to be feet squared, and that little 2 kind of reminds me of 2-dimensional, a flat surface. All right, let's try the next one. Oh, this one's that tricky part where they try to mess you up by giving you a diameter instead of a radius. All right, 2 pi r h plus 2 pi r squared, and surface area equals 2. I'm just going to type the pi symbol. And what do we have for the radius? Well, the diameter is 14, so the radius is 7. The height is 10 plus 2 pi, and then the radius in this case is 7, so we're going to do 7 squared. All right. Let's use our calculator. We have 7 and 10. Okay. So 2 pi times 7 times 10 plus 2 pi times 7 times 7. All right, and we're going to round to the nearest tenth again, so that's going to give us 747.7. 747.7, and in this case, it's going to be centimeters squared. Let's see if we got those two answers correct. 747.7 and 226.2. All right. Rewind and pause and work through your mistakes and see what you could do to improve if you need to. All right, let's go to the next problem. This is where reading directions will save you some time and energy. So we have a circular fence that is 2 feet high, is to be built around the outside of a carousel. The distance from the center of the carousel to the edge of the fence will be 35 feet. What is the area of the fence material that is needed to make the fence around the carousel? All right, so since we're just making the fence, I'll draw a little picture over here, right? We have the carousel in the middle, and then we have this fence that kind of goes around the outside, right? The fencing material, right? It does not have a top and doesn't have a bottom, okay? We're just looking for the outside area, okay? All around here, just the outside area. So in this case, we're just looking for the lateral surface area, just the lateral surface area. So you just need to use that formula, calculate, and you're good to go. Now, radius might be a little bit difficult, but if you read carefully, it says the distance from the center of the carousel to the edge of the fence, right? It's from the center to the edge is 35. So you can find the radius there, right? And the height of the fence is going to be 2 feet high. So 2. Okay. All right. Here are the answers. You can try these on your own. They're just different ways of finding kind of find the area of the label of a can of tuna. So the label doesn't go on the top of the can of tuna or the bottom of the can of tuna. It just stretches around that curved surface, which we call the lateral surface. So you're finding lateral area there. And then for part D, cylindrical candle with a diameter of 4 inches and a height. Okay, so find the total surface area of a cylindrical candle. So that is one where you're going to use the full surface area formula. Try it, see if you can get those answers. Hopefully, you're good to go here. All right. Here are some other practice problems if you want to try those and see if you can get the answers on your own. But hopefully this is just kind of a plug it into a formula, calculate, and get the answer, and it's not too challenging. Let me know if you're having trouble though, and I can help you out. Have a great day.